35 centimeter cube of hydrogen was packed with 12 centimeter cube of oxygen at 110 degrees Celsius and 760 millimeter mercury to produce steam. What percentage of the total volume of gas left after the reaction is hydrogen? Solution. From the question above, we have been made to understand that the reaction is between hydrogen gas and oxygen gas to produce steam. And that makes gay-lussac's law to be applicable amidst the gas laws we have. Gay-lussac's law of combining volumes states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volumes of the product if gaseous, provided the temperature and pressure remains constant. And another thing to note that it is only applicable to gases only. According to this question now, we are dealing with gases only. That is, we have hydrogen gas, we have oxygen gas to produce steam, which is also a gas. Before we do anything, the first thing to do is to write out the equation, the chemical equation showing the reaction between the hydrogen gas and oxygen gas. So now for that, we have hydrogen gas, which is H2, reacting with oxygen gas to give steam. Now to balance this, we have two atoms present of hydrogen, and same thing here as well. So oxygen, now we have two atoms of oxygen in the reactant side. Product side, we have one. So we'll be adding 2 as a coefficient. The oxygen gas is balanced, hydrogen gas now is unbalanced again. So now hydrogen gas in the product side, now we have hydrogen to be 4, and for hydrogen in the reactant side we have it to be 2. So we add 2 as well. So we have 4 atoms of hydrogen in the reactant side, product side we have 4 as well. And for oxygen in the reactant side we have 2, and in the product side we have 2 as well. So now we have a balanced chemical equation. Let's proceed. Since we are working with gay-lussac's law, the first thing to do is to write out the ratio in which the gases are combining. So now this is combining in the ratio of 2 to 1, and product as well we have 2. Hydrogen gas and oxygen gas are reacting in the ratio of 2 to 1. So if I have 10 centimeter cube of hydrogen gas, definitely I'll be needing 5 centimeter cube of oxygen gas. And if I have 4 centimeter cube of oxygen gas, same thing, I'll be also be needing 8 centimeter cube of hydrogen gas because of the ratio in which they are combining. Now going back to the question, what percentage of the volume of gas left after the reaction is hydrogen? That is, after which the reaction is complete, what percentage of the residual gas, which is also referred to as the total volume of the gas left, that is, the volume of the gas left can also be called the residual gas, that is gas left after the reaction, is hydrogen. So now we can conclude that the residual gas is hydrogen, which simply means that oxygen is being used up in the reaction. So now, since oxygen is being used up and we have 12 centimeter cube of oxygen given, so I have 12 centimeter cube here, what volume of hydrogen gas will be required for the complete reaction? So now I have them reacting in the ratio of 2 to 1. So now if I now have 12 centimeter cube of oxygen gas, then what volume of hydrogen gas will be needed? So to do that, I will say X equals 12 centimeter cube multiplied by 2 divided by 1, which is equal to 24 centimeter cube. That means I now have 24 centimeter cube combining with 12 centimeter cube of oxygen gas to also give 24 centimeter cube of steam. Now let's not forget that our residual gas is hydrogen, and we want to know the percentage of the residual gas. So now moving forward, we can state that initial volume of hydrogen gas is 35 centimeter cube. Then the final volume now, the volume that reacted, equals 24 centimeter cube. So what is the volume of the gas left unreacted? That is, what is the volume of the residual gas? So we can now say that volume of gas left equals 35 centimeter cube minus 24 centimeter cube, which is equal to 11 centimeter cube. Now I've gotten the volume of the gas left, that is hydrogen gas left, to be 11 centimeter cube. So what percentage of this gas is left? So to get the percentage now, percentage of hydrogen gas will then be the volume of the gas left, 11 centimeter cube, divided by the initial volume of the gas, which is 35 centimeter cube, multiplied by 100. So we have 1100 over 35. Then our unit in percentage, which is equivalent to 31.4%, and can also be approximated to 31. So we just calculated the percentage of the gas left after which the reaction has occurred, and given the volume of the gas left to be 11 centimeter cube and the initial volume of the gas to be 35 centimeter cube, I mean hydrogen gas, then the percentage is gotten to be 31, and that serves as the final answer. That will be all on that. Kindly subscribe and as well click the notification bell so as to get notified as soon as new videos are being posted. Thank you.